Hi guys, welcome back. In previous video, we discussed about basics of a transistor, what is meant by transistor, and different types of transistors. Uh, we mainly discussing about this bipolar transistor itself. In this video, we are going to discuss about configurations of an transistor. We have three types of configuration. Uh, one is one is common base configuration. Just remember these uh, letters which are written in black. These are majorly important because based upon these, even if you forgot everything about these transistors, you can write a paragraph, up to a paragraph based on this. Just a line. Common base configuration means has voltage gain but no current gain. Just I will write a matrix form for this. Just I will tick the things which it has, like voltage, current, common base, common emitter, common collector. It has voltage gain but no current gain. Okay, now common emitter configuration, both current gain and voltage gain. Common emitter configuration is both voltage gain and current gain. And common collector configuration has current gain but no voltage gain. No voltage gain, but it has current gain. Just try to by heart this matrix math because it's very important for your semester exams. Trust me, this is very important. You can expect this question directly. Transistor configuration. As a bipolar transistor is a three-terminal device. There are basically three possible ways to connect it with an electric circuit, with one terminal being common to both the inputs and outputs. Each method of connection responding differently to its input signal within a circuit, as a characteristics of the transistor vary with each circuit arrangement. What this resembles is we have three types of what we call terminals in a transistor. Just like whether it might be an PNP or NPN, we have three terminals, right? Just consider PNP. In one can be connected another one way, and whether it one of the P is connected to positive or negative, other will be connected to the opposite of its side. That's what it mentioned. With one terminal being common to both the input and output. See, this terminal is common for input and output, and this is the only one which is different. If you are going to vary the connection of an terminal in every circuit, I mean the circuit connection, if you are going to connect this this thing to the main circuit and left to this as an input and output, if you are going to connect it as an input and if you are going to take both of them as outputs, if you are going to connect this as an input and if you are going to connect these two as an outputs, we are based upon different configuration, we are going to get different output of voltage and current. That's the main advantage of this transistors. And common emitter configuration is the one of the most used configuration in this transistors. For our daily usage purpose, we use this configuration the most. Now we will look one after another. First thing is common base configuration. Common base configuration in the sense, as its name suggests, the common base or grounded base configuration. Here, just look at this name. The common base or emitter or anything it might be, the common letter represents the it was grounded. In every configuration, if it's common emitter, then emitter is grounded. If it is common uh, collector, then collector is grounded. Just remember this like this, grounded. Okay. As it the common base configuration, as the name suggests, in the common base or grounded base configuration, the base connection is common to both the inputs signal and the output signal, with the input signal being applied between the base and the emitter terminal. You see, it is the input and we are applying it between emitter and base, and the corresponding output signal is taken from between the base and the collector. We are taking the output from here, shown with the base terminal grounded or connected to the fixed reference voltage. Yeah, and we are connecting this base to the and we are connecting this base to a zero voltage or a fixed reference voltage. Just try to memorize this circuit diagram. we are applying voltage V here. It is an alternating voltage in which we are taking the input signal from the circuit, from the emitter, and we are traversing back the excess amount of voltage to the ground, and we are taking the output signal from the collector. This is the common base configuration circuit diagram. And from the emitter, from the collector, we are taking out the output voltage, whether it might be an magnified or demagnified, something else, we don't know. We are taking, just look at these characteristic curves, you might get an idea. This is all about common base configuration. If you are going to consider the common emitter configuration, in common emitter configuration, the grounded emitter configuration, the input signal is applied between the base while the output signal is taken between the collector and the emitter. Just see, in common emitter will be grounded, right? Yeah, just look at it. Emitter is being grounded. And now we are taking the input signal from the base and we are collecting the output from here. And we are collecting the output from here. Just look at it. We are collecting from base and the emitter as shown in the figure. The type of configuration is mostly used for circuits for transistor-based amplifiers and which represent the normal method of bipolar transistor. That's what I mentioned. Right? It is the most common configuration of BJT transistors, because it is the most uh, it is most widely used in amplifiers for increasing the input signal and reusing it. For those purposes, we use this type of configuration transistors. Okay, right? This is the advantage of this transistor, this transistor configuration. And another leftover is common collector configuration. The common collector configuration name suggests the collector is grounded. Yeah, I just gave you a circuit diagram for two configurations. I just want you guys to have draw this diagram for this configuration. And the hint for the whole drawing is given over here. If you are able to draw it, then it's well and good. If you're not able to draw it, I will pin the link for the diagram in the comments. Just look at it. I will give you the hint regarding this. In common collector or grounded collector configuration, the collector is now common through the supply. The input signal is connected directly to the base. Just look at base is input signal, while the output is taken from the emitter as shown in the figure. I didn't attach any figure over here. This type of configuration is commonly known as voltage follower or emitter follower circuit. The emitter follower is the current amplifying that has no voltage gain. In previous common emitter configuration, there we observed the amplification of both current and voltage is taken over there. But here in this configuration, only current amplification will be done. Current amplification, but no voltage voltage amplification. These are the key points. That's it, guys. If you are able to remember this, and you can write a story regarding this. The important characteristics are the important characteristics of a common collector configuration. No voltage gain. It has a high impedance and low output impedance. High input impedance and low output impedance. Relatively high current and power gain. Just mark this as an important, very important point. Input and output arc voltages are in phase. The phase of input and output voltages are same. That in the sense, if you are going to send a positive part of an voltage, then you are also going to get output as a positive part. If you are going to send a negative part of an voltage, that means sinusoidal, as the alternating current is sinusoidal in nature, we are going to get output as also a negative voltage, like that. Characteristics of this transistor: when the transistor is saturated, VCE, that in the sense voltage over no voltage gain we wrote, right? That's what here written. VCE will be 0. When transistor is off, I saturate. is equal to VCC common collector divided by RCC. That's it, guys. I think this is all for this video, guys. Thank you. Meet you in the next video.